Okay, so today's lesson in Python will be numbers. And before I get into it, I will just give a quick context of what we're talking about here. Okay, so Python has a hierarchy, right? And any program in Python can be basically split up into modules, statements, expressions, and objects. Programs are composed of modules. Okay, number two, these modules contain statements. Number three, these statements have within them expressions. Number four, these expressions create and process the objects that are either built into Python or otherwise. So, so basically, built-in objects in Python are always better to use. Okay, and the reason for that is because the built-in object types makes the programming smoother, and they're more efficient and more powerful of what you can create from scratch. Um, so, and they're the core of every Python program. So try to always use these built-in object types. Now, what are these built-in object types? So there are many. Okay, we will go through each in separate videos, so we can keep this short and and brief and productive. So these object types can be. I will just list them really quick. So we have numbers, we have strings, we have lists, we have dictionaries, tuples, files, sets. There's other core types like booleans, and there's program unit types like functions, modules, classes, etc., etc. Okay, and many more. So in this tutorial, I will focus on numbers. So numbers, as you know, Python can handle numbers very, very efficiently. Whether we're talking about integers, so numbers can be integers with no fractions. There's floating point numbers that have fractions, right? There's complex numbers. There's decimals that have fixed precisions. There's rationals with numerator and denominator, etc., etc. So Python can handle all of these. Okay, and while we are at it, let me just say that Python can be used as a calculator. It can even be used as a scientific calculator. So you can perform all kinds of operations that you do on any calculator within a Python module. So for example, you can add. So I could say here 40 plus 90 and hit enter. On a Mac, it's shift return and it's going to give you the answer, 130. Okay. Now, multiplication in Python is a star. So 3 times 3 is 9. And then exponentiation, if you want to raise to the power, that's 2 stars. So if I do 3 squared, I will get 9. Okay. Um, that's for numbers. Now, sometimes what you need to do is let me show you something here. Let me restart this kernel. Let's say you have some kind of mathematical constant that you want to use. You wanna know what 2 times pi is. Okay, so Python can handle this, but there's a caveat to that. So if you hit this, you get an error, right? Not name pi is not defined because it's not here. So you have to import that library that has pi. So there's many libraries that have pi in it. There's the math library, the numpy library. So for that to work, you should import that first. So you can say from math or numpy. I'll just use math. From import, you can say import pi. So now Python knows what pi is, and then when you do 2 times pi, it understands that pi has the value of 3.28, and it'll give you an answer, 6.28. Similarly, if you're doing trigonometry, sine, cosine, tangent, so like if you type sine, let's say 30, right? Oops, sine 30. Oh, by the way, Command Z on the Mac will undo your last action. If you made a mistake and you don't want to go back and type the whole thing, you can just do Command Z. Okay, so here's same thing. Name sign is not defined. So I can go back to that first line, and where I imported pi, I can import sign, right? And then now when I enter this, oops, maybe it has to be in that same block. Oh, I have to run the block, right? Once you import something, you have to run the block. and then you can see that it tells me minus 0.9. Now this is not degrees, by the way, this is like radians. So that's why it outputted this. This is 30 radians. Okay, so now and then cosine and tangent, etc. Now if you're tired, let's say you are importing so many things from the library and you don't want to keep writing them down, cosine, etc., etc., what you can do is you can import the entire library. So you can say from math, or import math as, and then you give it some name, mth. Okay, but now the trick is, every time you use something from the library, you're gonna have to say mth dot sign, or empty, you understand, so that it knows that you are actually using from library that you called mth or math. Let's just keep it math, import math as math. Okay, but basically I'm using the second name here. So math sign, and then if I say pi, right, and then you can see the answer. The answer should be 0. Sine pi is 0, but this has to do with precision and so on. So it gives you a very, very small. It's almost 0. 0.15 0 is 1. Okay, so that's 0. You can also do print, right? You can print this. So you can say print and then put this guy in parentheses, and you get the same thing. Okay, I think. Oh, one more thing. You can import. You can do random numbers in Python. So, but you have to import random. So if I import random, then I can choose random numbers. So I could say random dot random, which means random the library, and random, I need a random number, parentheses, and it gives me a random number, 0.219, right? So that's also a neat trick with numbers. Okay, I think that's it. So numbers are very straightforward. There's more. There's quite a bit of more. I will deal with this in a longer video in the future, but now since I'm covering the basics, we will just say this. Okay, thank you for watching. If you like the content, please don't forget to subscribe, like, and comment. And if you are capable and willing to consider supporting us in continuing to make this free and available education to the public, you can donate to this cause. The description is in the link, the email for the PayPal. We would appreciate it too. Have a good day. Thank you.